Okay, pa, vanakkam. Good morning. Good morning.
Good morning, sir.
Morning, vanakkam.
Good morning, sir.
Vanakkam, vanakkam. Amitavarsini and some other. Okay. மூணாவது கிளாஸ் அந்த வாரத்தோட இன்னைக்கு 10 கிளாஸ் வர போகுது நினைக்கிறேன். Suppose okay. I need to upload two of this recent class videos. The other things are already done. Okay. Let me take today's content. Okay, let's share this content. Okay. Better everything sharing. Yeah. Okay, screen. So that I want. எத்தனை பேர் ஒரு 22 ஸ்டூடெண்ட்ஸ் ஆர் அவைலபிள். ஓகே குட். எல்லாம் சாப்பிட்டீங்களாப்பா காலையில? பிரேக்ஃபாஸ்ட் ஆர் பிரேக்ஃபாஸ்ட் will be only happy to see you, happy to know that even because sometimes because of this lockdown there is a tendency for people to relax. Of course it is also needed not sometimes, but to utilize this opportunity. Otherwise very rarely we'll be getting this kind of long vacation. Kind of vacation, not vacation. At least you can do your own duty at your own pace. Of course, a lot of new learnings are happening in this season. Yeah, even I said about this, my new activity. No, this in the last year by April only I started this gardening, and I could now see this result of the gardening. I can see a lot of this papaya trees are giving these fruits. 3-4, yeah, more than 3-4 papaya trees are available, and they started yielding fruits, giving fruits. A lot of grains I could have, and murunga maram, what is it, drumstick? Yeah, drumstick plants. Some 3 trees are available, and 3 banana trees are available. And of course, banana tree will take some time. You know how much time this needed for any plant to yield? No, any of you from of course, some of you are from agricultural background. Of course, many are in city background now. Even the otherwise, your previous generation maybe from this agricultural background. Now they changed. Even my parents are did agriculture, and even I used to go to the fields till my college days. No, once I finished my college, I could I could not support to farming, and that lead to even selling of all our agricultural land. Of course, this is a scenario everywhere. As and when the family members are studying, they could not continue their old the traditional work. How about any of you are having access to this farming at least now, at least with your parents or grandparents, with your grandparents? Parents will be, they will be with you. Ambika, எப்படிமா இருக்கு? என்னமா பண்றீங்க அம்பிகா?
ஃபார்மிங் தான் சார் பண்றோம்.
என்னென்ன பண்றீங்க அங்க? உங்க என்னென்ன விளையும் உங்க ஏரியால?
நெல், வேர்க்கடலை, கேழ்வரகு எல்லாமே விளையும் சார்.
சூப்பர்மா, நல்லது, சந்தோஷம். நெல்ல என்னென்ன வெரைட்டி போடுவீங்க? நெல்ல நிறைய வெரைட்டி சொல்லுவாங்க இல்லையா?
எஸ் சார். அது பேர்
தெரியல. ஓகே, நோ ப்ராப்ளம்.
எஸ் சார்.
நைஸ், தேங்க்ஸ் மா. ஹேப்பி டு எத்தனை ஏக்கர் கேட்டீங்கன்னா அது வந்து இட்ஸ் கைண்ட் ஆஃப்
1.55 சார். 1.5 சார்.
பத்தாதேமா, ரொம்ப கம்மி இல்ல?
எஸ் சார்.
Maybe it will be sufficient for your requirement. You cannot sell to the sell for people as like us. இல்லையா? நிறைய விற்க முடியாது. விற்கிற அளவுக்கு பெருசா வராது.
எஸ் சார்.
The rated question is, can any of you say about the yield of this agricultural lands? Of course, it is not needed to this subject, but that is also needed. No, that is a primary requirement for any human being. Food requirements. Maybe I will ask from some other students, because Ambika can easily answer this question. How much is the yield per acre of this rice or any other vegetable produce? எவ்வளவு கிடைக்கும்? சரி, ஓகே, இதெல்லாம் தெரிஞ்சுக்க ட்ரை பண்ணுங்க. அட்லீஸ்ட் நெல்லுனா தர்மேஷ்
sir, it depends on the fertility of land, sir.
Yeah, fine. At least some average yield you can give,
Like sir,
20
20 quintal, like
20 quintal.
Uh,
Correct,
20,
no?
20 tons.
20 tons. 20 tons is very huge, man. 20 tons is 2000. Yeah. What is it? Yeah, 2000 kg. No, correct. Sorry. 20 into another 1000. It will be too much, pa. 20 tons not possible from acre. You know, the one ton is 1000 kg.
Sir,
சொல்லுங்கம்மா அம்பிகா.
it may be 1 to 5, sir.
1 to 5 ton.
Maximum
Ton.
3.
1 to 5 ton.
Sir.
1 to 3 ton.
Yes, sir.
Correct. That means 30 மூடை
Yes,
கிடைக்கும்.
sir.
Yeah, 30 மூடையா sacks of
Yes,
rice.
sir.
20 ton thermos, that will be very huge, pa. Maybe very, I don't know. Are you sure of that? 20 tons thermos? Since gave that answer, no?
Not sure.
Not
Not
sure.
sure.
Not sure. Okay. Because at least I can say like on the average about 15 sacks. Every sack will be about nearly about 100 kg in the case of this items like tur dal and other thing. Right, dal and all, they will be weighing about 100 kg, whereas most of the items will be weighing lesser. Of course, these are all some idea one should know, because a person should be capable of growing his own food. At least that idea came very recently to me, and now at least I could make some greens, thanks to Corona. Because we were given with a lot of time to work from home. At least I could avoid some 3 hours of travel, and likewise you people also now lucky to avoid this travel, so use that time for any other useful activity. Okay, because sometime occasionally we should also come out of the subject and know this what is happening around, and what is the purpose of our life or something, no? Because this and all normally not taught in this engineering classes. Okay, occasionally we'll see that. Okay, coming back to the subject. We are I'll again see the this physicochemical calculations, energy equivalent mass, concept of material and energy balance. Only this is the information available in the syllabus content. Still I am elaborating whatever is needed for the subject. Okay, otherwise I'm giving about overview of mass and energy balance. That is very explicitly mentioned. The other two aspects, various process streams and terminologies, I'm just adding so that you can also understand the future chapters and also the coming year semester classes. Okay, that. Okay, to quickly say this, unsteady state means time varying behavior, whereas steady state time invariant behavior. And you know, with chemical reaction there are consumption and generation. Without chemical there is no reaction, there is no such thing. And material balance, it is simply mass and whereas energy, it is the energy content, this is in joules, this joules are calorie, this is in kg. Okay, energy normally will use this joule unit. Most of our units we are simply using in SI. SI unit of energy is joule, whereas this European and US people are still using this system of unit. What is it? BTU. That is for energy term and like that. So at least you should be you should not worry about this conversions and all. Of course, the conversion factors are readily available. You can replace with a terminal, with make necessary conversion and use that. Okay, the general equation is very easily understandable, and this reduces to this kind of condition under steady state and no reaction, input equal to output. So this is a case we'll use in our most of our subjects like what is it, fluid mechanics, heat transfer, mass transfer. So in that case you'll be having simply input equal to output. So whatever the governing equation, always our mass balance equation is very simple. So in addition to this energy balance and mass balance, you'll be using what is called as some constitutive equations. They are coming from some laws like law of heat transfer and law of diffusion and law of what is it, momentum transfer. These are all there too. They will be coming there, and you will be making use of that relations to arrive at the necessary relations. Okay, that and all we'll see in the coming chapters. No need to worry now. So atom balance is very convenient whenever you don't know the reaction pattern and we don't know the exact reaction what is happening. But it for sure whatever atom entering is should leave under steady state. Of course, under unsteady you will be having there is accumulation. Of course, I already said we'll be most of the time dealing with steady state situations. The unsteady state part is covered in a course what is called as process dynamics and control. Of course, in the last semester I had taken that course. Even I have given that entire lecture of that contents are available in my YouTube channel. Otherwise, I have put up these contents in YouTube. If those who are interested, they can also see that. Of course, slightly going away from this idea is at least. Let me see. Yeah, my class contents are put up here. Of course, there may be very less number of views and subscribers. You can also go through that. Otherwise, simply search for msubbu. Otherwise, my short name is simply msubbu. Msubbu. Otherwise, M refers to my father's name Mukaya, and CH I added for our convenience. Okay, msubbu. You can simply reach msubbu and wherein which my entire class notes and class lectures on process control is available. Those who are interested, they can also listen to that lectures. Of course, slightly advanced level. Only after this second year you can take up that lectures. Okay, now coming back. Okay, in the last class we started about this conversion, and even one of you also finished this aspect. Gautama, who finished this calculation and he gave in the chart also. There is I am asking about how to convert this to mole fraction to mass fraction. Okay, answer is already I gave, and even one of you also worked out this thing. And sorry, Gautama, who finished this zone, who has Gautam. Thank you, Gautam. Okay, the question is now, are you able to make this conversion now? Make this conversion by yourself. I gave the list of always the steps and the answer as well. Or should I work it out? I will ask maybe one of the nice student. Even Ambika, are you able to work out, ma? Because she came forward to answer some of the questions.
No, sir.
Okay. We'll take this and make it in the Excel. Excel so that I will. Okay, I'm going to do this in Excel. Of course, Excel is a very nice tool, available for everyone. Of course, elasticity, I almost Excel. Okay, let us write these informations. My screen is visible, no? Oxygen, nitrogen. Let us slightly zoom. Okay. It's about simple most of the time we'll be having this composition either in mass percent or volume percent, not volume percent, normally mole percent and weight percent we'll be having. So sometimes this for chemical engineering reactions and all, we are very comfortable in terms of moles, because we know from the stoichiometry we will come to that. Option is 21. Okay, what is it? 21%, and this nitrogen is 79%. This is in mole percent or volume percent. Okay, we'll take simply right mole percent, and so this is in mole percent. So for a basis of for 100 moles, let us choose a basis. Mole percent. This is for so let us take 100 mole or 1 mole for 1 mole of the mixture. Otherwise, for any chemical engineering calculation, normally we'll start from the basis. Basis 1 mole of air. Okay, this because we are given with the composition, we are asked to express the composition in terms of other basis. So this is a basis. We'll leave a blank. Okay, and remove these things because we need space. Okay, and So let us write this molecular weight. Molecular weight is 32 and 29 parts. It's an approximate. Okay, for 1 mole of air, how much mole of oxygen is available? This 0.21 and this is 0.79. How do we write? Because this percentage, no? Fine. And this is in mass. Mass is, mass is equal to mole. Mass equal to mole into molecular weight. Yeah, simple only. Because the definition of molecular weight is like that. Molecular weight is mass per mole. Or we will normally use this to be MW. MW or sometimes M itself. So what is the mass of this 0.1 mole of oxygen? That is moles into molecular weight. Because molecular weight is gram per mole or kg per k mole. It is not kg mole, it is k mole, right? Right, and likewise, once you do this, and you can simply take that copy paste. So Excel is very convenient. When you type a formula for one cell, for the subsequent cells, you can easily copy the formula. Excel use pannrீங்களாப்பா? Any of you are having a nice usage of Excel, using this Excel effectively? Otherwise, also please start learning this Excel. You can use this Excel effectively for all your calculations. Meenakshi Sundaram, you are trying. How about Dharmesh? Used to you people know this Excel? Okay. So Excel கொஞ்சம் யூஸ் பண்ணுங்க நல்லா. Excel you can easily learn. Dharmesh?
Yes, sir.
Yes, nice. Happy to know that. Because Excel is a very nice tool, convenient tool. Though people used to say like hi-fi softwares, but these softwares are readily available. No? So whatever is readily available, you should know and have excellent use of that. Even I will, based on my experience with the Excel and other softwares, I would say like this Excel is an excellent product, excellent software for engineers. So try using to the extent possible. Okay, fine. So this mass is in okay. This is in mole, mass in gram. Fine. Now G refers to gram, and so what is the total mass available? You can simply make use of this summation auto sum. Otherwise, how do you write? Formula equal to sum of. You can simply specify the range. So here the F7 to F8 is the range of data. So this is a you can say like this average molecular weight. Average molecular weight of air is 29.63. It is coming. Okay. Actually, normally we used to take 20. Yeah, this is gram moles into molecular weight. Okay, this is molecular weight. Okay, now mass percentage. Simple only. This is this divide by this one. And okay, even I can teach Excel as well easily. If you simply copy this formula, what will happen? It will give the error. Okay, I'm giving you a point to learn. Why this error is coming? Because this cell is fine. Mass by total mass. If you try to copy the formula is by default copied in a relative manner. See, for example here. So it is taking this. So this cell is taking formula, this and or cell would it is taking. Likewise, this also taking in the same way. Whereas suppose you want to have this formula or this cell to be this cell contents in this denominator should be simply F9. It should not be anything else. So you should have this prefixing of this row and column identifier with $. If you do that way, you can simply drag copy this now. So now you can easily get in terms of this is mass fraction. That is to get percentage, simply multiply these contents with 100. Okay, so you are getting this in terms of 100. So simply for round off, you used to like say like, okay, these are all formatting options 22.7 and 77.3 to be precise. Otherwise, 23 and 77. Is it understandable, Pam? This thing is, even this I can upload in this PC. Okay, class contents. Mole to mass percent. Is it understandable, Ma? Simple one, Otherwise, what is there? The given data is in moles, and we know the molecular weight data. Don't worry, these data are supposed to be given to you. And of course, for some known components like oxygen, nitrogen, carbon, and what else, sulfur, chlorine. So for these kind of even sodium, for these kind of components, you can have an idea of this molecular weight, because these are all the most used components like oxygen, nitrogen, sulfur. Okay, so this is a mass percentage. Clear only. I suppose it is understandable. Purinchilaba, Ambika, you are able to understand, and Dharmesh.
Yes, sir.
Nice. Even I should also ask other students, because the people will also get bored. Varsini, where are you from? Sri Varsini, I know she is from Dharmaburi. The another student named Varsini is also available. No, I don't know whether today our class Varsini is not seen. William Varsini today class. Okay.
Sir.
Varsini. I am asking Varsini, not Sri Varsini. Varsini.
Okay, sir. Okay, sir.
Because Sri Varsini, I have talked with you many instances. At least because of you also like travel, and also I like travel. Of course, many will be liking travel, but you should enjoy that travel. Nice, ma. So I'm asking Sri Varsini, Varsini irukangala? I'm asking the student Varsini. I will try to involve students, other students as well. Class, no problem. Varsini and where a student.
Yes, sir.
Sorry, where are you from, Varsini? Because I'm always interacting with the other Varsini.
I'm from
Tirunelveli. Oh, enga ma Tirunelveli satham kekka madi. Your voice is very not audible. Okay, if you don't, if you could not make it, you can type in the chat. You are from Tirunelveli, yeah? Nice. Okay, ma, you try. Thanks for your answering. Yeah, fine. So this aspect is clear, I suppose. Over. Simply moles, molecular weight, you will be getting you know the moles and molecular weight is available, mass is not, so you can get mass fraction. Simply, this kind of conversions we normally use making many times. Otherwise, we'll do the reverse most of the time. Like we are given with a mass percentage, you'll be asking the mole percentage, because in the chemical reactions, say like sulfur plus oxygen turning to sulfur dioxide, our known reaction. Say we know based on the stoichiometry of the reaction, I will use better other sheet. No, say for example, fine. So this reaction is sulfur plus O2 turning to SO2, and likewise the other reaction, say RSO2 plus half O2, no, or half O2 leading to SO3. So for this kind of reactions, we can easily say based on the mole numbers. No, say 1 mole of sulfur reacts with 1 mole of oxygen to get 1 mole of sulfur dioxide. Whereas we cannot say like 1 kg of sulfur reacts with 1 kg of O2 and get 1 kg of. Otherwise, in terms of only in stoichiometric number, or what is called as mole numbers. There is a direct correspondence between stoichiometric and moles. Okay, so this. We can easily say this chemical reactive systems in terms of mole basis. So for in terms of mole basis, we can easily say like for 1 mole of sulfur, we need 1 mole of oxygen for stoichiometric reaction. Of course, most of the time we said extra moles of oxygen so as to ensure that entire sulfur is utilized, because sulfur is costly in comparison to oxygen. Of course, now oxygen is very costly. No? We are struggling a lot to get this oxygen. Now almost people are capable of meeting their oxygen requirements. Slowly the cases are declining. So otherwise, coming back, of course, in industry, we don't use this pure oxygen. We'll simply take air, which is a mixture. No? So whatever the nitrogen remaining, or is nitrogen available in the air, is not taking part in the reaction. Otherwise, this again a nice property of this nitrogen. Of course, this nature system is very fantastic. So because we God always we know always there is a large need of oxygen, but oxygen is available in the safe level. If the entire atmosphere is of oxygen, then it will be creating a lot of problems. You know the problem of oxygen, no? This leading to fire everywhere, because with this because of this availability of nitrogen in sufficient level, it is not catching fire easily. Otherwise, we should spend some time to even appreciate the properties of nature, no? Wonderful design. Like this, oxygen is getting reacted easily, whereas nitrogen remains inert for most of the chemical reactions. So what will happen even in the case of the sulfuric acid production? This air is entering, in that oxygen is utilized in the reaction. Nitrogen stays as inert. Of course, it's also a problem in terms of these reactions, like combustion reactions. In the IC engines, let's say whatever the fuel you are using, for combustion of the fuel, we take the nitrogen, we take the oxygen, air, and air is having nitrogen. And the combustion reactions are normally up to about 1000 degrees Celsius. At that temperature, nitrogen is turning to nitrogen oxides. So these nitrogen oxides, of course, it is not effectively. Of course, nitrogen oxide generation will be huge, no? Whereas sulfur content in the fuel is very lesser, whereas nitrogen content is there in large amount in the air, so which is combining with the oxygen, which is part of your air. So that is again going to create a lot of problems. So to avoid that, normally they are having this catalytic converters at the exit, which is again making some conversions to this. Otherwise, NODs, this NOx is effectively trapped there. Otherwise, it is a very huge, powerful pollutant. Okay, otherwise, nature's design is great. And again, coming back to our thing, this conversion of mole fraction to mass fraction, this is very commonly used. The reason is most of the time, most of the chemical reactions we use to make the balance in terms of moles. See, even we represent the concentration in terms of say moles per so much of gram moles or k moles per liter or meter cube. There is the concentration units like moles per liter. This is very common, no? Mole per liter. LTR we'll use, or sometimes LIT ER or LITRE. There are again this British and English, British and American English. LITER or LITRE, both are interchangeably used, or for convenience, we use this LTR, liter. So 2 moles per liter. So these are all are 2 moles per meter cube. So these are all some kind of units we'll be seeing in your. There is some data you'll see in your chemical reaction engineering course. Whereas in fluid mechanics and heat transfer, we are comfortable in terms of kg. Because for which there is no change of no reaction as such is happening. So the very convenient thing is kg unit is very understandable. And for again convenience, for water, 1 liter is 1 kg. Likewise, in comparison to water's density, we'll have this relative, and most of the materials are having density as closer to that of water. Sometimes metals will have some 4 or 5 times, even 8 times denser as that of even 13.6 times. No, which metal is the highest high density metal? Of course, 13.6 is associated with mercury. You know that. Okay, let us not deviate much from the subject. We'll come to the next topic is about sensible. For energy balance, we'll use this data like specific heat and latent heat. So for that, we need to know about 2 sort of heat. One heat is one terminology. There is what is called sensible heat. This sensible heat is identified with change of temperature. Whenever you heat a liquid or gas or vapor, whatever material, if the temperature of during heating, if the temperature of the substance is increasing, that indicates there is a sensible change happening. Sensible means you can sense the change. Okay, you can put a thermometer and see the heating happening. You can observe the, or you can identify there is definitely a heating. Of course, we used to use this kind of கையை வச்சு நீங்க செக் பண்ணீங்களா டெம்பரேச்சர் யுவர் ஃபார் செக்கிங் ஃபார் யுவர் என்னதுப்பா ஜுரம்லாம் இருக்கான்னு பாக்க ஃபீவர் டு ஐடென்டிஃபை வெதர் யூ ஹேவ் ஃபீவர் ஆர் நாட் யூல் யூஸ் யுவர் hand like this. I can ask a related question. Why don't we use this way? My video is visible now. Yeah, let me check whether this okay. நம்ம ஜுரம் அடிக்கும் போது ஏன்பா எப்படி வச்சு பாக்குறோம்? Or here somewhere. Why don't we use this what is it, the front side of our hand, forehand? Any of you can give the reason? The question is, why do we check the temperature by this back side of our hand? Why not this way? People are very great people, pa. Question is, the question is clear now, pa? Sorry, I have to remove this. Click panna here, fine. The question is, why do we use what is it, back side of the hand to check the temperature? Why not we use this way? Okay, I did not ask this question. Maybe some of you will answer by Google as well. Okay, another thing is latent heat. Otherwise, whenever you add some energy to a substance, if the substance is not showing any change in temperature, of course, it is taking heat, but so though there is a lot of addition of heat or removal of heat, if the substance of the if the temperature of the substance doesn't change, it indicates that there is some sort of phase change happening. Say for example, okay, during phase change, the temperature is simply remaining constant, but there is a large addition of energy. There is in proportion to the latent heat. Okay, that heat and all will come to that. So this is about during sensible heat addition, there is a change of temperature that you can easily identify. Say for example, water at 0 degrees Celsius is available, and to which you are keep on adding heat till at a temperature of 100 degrees Celsius, you will see the change in temperature. Otherwise, these are all happening in atmospheric pressure. Otherwise, how do you take water at 0 degrees Celsius? You allow the ice to melt, and you will be having 0 degree water. You can raise the temperature by adding heat. And if you linearly heat the thing, you will see change in temperature this way. And you will once the entire liquid is standing, liquid is rising, getting rise to a temperature of 100 degrees Celsius, then you'll see the liquid is turning to vapor. During this during this condition, or is till the entire liquid is turning to vapor, you will see the temperature of the vapor is remaining constant. Here, this you have ice, and till the entire ice is turning to water, you will see the temperature is remaining constant. So these are all nothing but latent heat. Otherwise, during latent heat, there is no latent heat change. Otherwise, latent heat absorption or removal, there is no change in temperature. That's why latent means it is within. Whereas sensible, it is identifiable easily. Otherwise, this latent heat absorption or rejection are happening during phase change. Say this solid to liquid or liquid to vapor, or the reverse also. Of course, luckily the reverse also requiring the same amount of heat. There is vapor to liquid, latent heat of condensation. And here this is latent heat of freezing. Yeah, right, freezing. Melting, this is heat addition, and again vaporization, and this condensation, and again heat removal, sensible heat removal, and again freezing. Okay, in terms of energy level, this is this, yeah, energy is keep on rising with addition of, with increase of temperature. And during phase change, you can see this temperature is remaining constant, or is this x-axis is remaining constant, this y-axis increasing, or is this vertical rise is equal to the latent heat of vaporization, or latent heat of say this is latent heat of melting and latent heat of vaporization. So the of course this latent heat content is again is reported in the data, and these are all most of the time needed for our calculations. Say this data of water now is effectively used because the power plant data, the power plant calculations. So power plant calculations is simply involved in with this latent heat of vaporization of water and condensation. That is the same thing at different pressures levels. So they will use this data. This for water, the data are available in a table what is called a steam table. Steam table. Of course, you also supposed to buy one such table. What is called a steam table. Steam. STEAM. Steam is say water vapor. No. So this steam, the data are available at variety of temperature. Always the internal, what is called as internal energy and enthalpy and volume data. Of course, I can show you one such specific. I don't have because I need to connect my hard disk, which is not available. Okay, so this maybe I'll check for that. So this. Okay, it's not available in this content. Fine, not necessary now. So this steam table will be effectively used in your chemical engineering studies. Okay, simply listing the properties of water in various states. Water in mostly in vapor state and liquid state. So for water, what is pressure temperature connection? Or is this simply relating this PVT behavior, pressure volume temperature behavior of this water. Okay, so far we simply discussed about two types of heat, which is sensible and latent heat. So during latent heat addition, temperature remains constant. During sensible heat addition, latent heat changes happening whenever there is a phase change. Okay, here there is a no change in phase, but the temperature of the material changes. Here, as like here also we can have a another linear line which indicates the vapor is turning to superheated vapor. Otherwise, there are variety of states. This is fully solid at this point, or is this extreme point? I will so at here, no, 1 minute. Or is here you'll be having fully solid and fully liquid, and here it is starting of vapor, and here you'll be having saturated vapor. Further addition of heat will lead to superheating the contents. Okay, there are terminology what is called as superheated vapor and simply saturated vapor. Okay, this and all you will again get clarified in your coming semester, what is called as thermodynamics. Now we are going to the next aspect, which is process streams. This also again related to stoichiometry. Otherwise, we are still in stoichiometry. Maybe one more class also we will discuss for this finishing this aspect. That is on coming Monday. Coming Monday, Wednesday we'll be having a class, and possibly on Thursday your test will start. Test no timetable anupla illapa. Test timetable not apply. Okay. So we can comfortably finish this stoichiometric aspect of unit 2. The fluid mechanics aspect will start once test is over. Once the first test is over. Otherwise, if there is any delay in start of this first test, we'll also cover this fluid mechanics. We'll try to take up some aspects of fluid mechanics. Okay, coming to the process streams. See, in the chemical engineering or chemical industry, or not only in chemical industry, any reactive system, not all the feeds are converted into product. So there is simply we cannot simply write a thing like feed equal to product. Otherwise, feed passing through a reactor is leading to any product. There is always a kind of waste getting generated. Of course, we know this our whatever the food we eat also, it's not completely converted to energy, not completely utilized. Definitely we need to waste a lot of contents, and sometimes there is a kind of what is it, recycle happening. Say normally this like our cattle and all, no, this erma madu, pasamadu, or even this goats, what they used to do, they whatever the grass they see, they keep on consume, but it is not immediately digested or immediately not converted to the liquid form. So what they are doing, they are simply accumulating that in their stomach, and later they will be again bringing that to the mouth area, and they will be again crushing them. What is called as the மாடுகள்லாம் அசை போடுதுன்னு சொல்லுவாங்களே, அசை. Tamil, I don't know the exact word in English. Otherwise, they are bringing back the contents and again reacting, allowing it to make some conversions. So otherwise, there is a recycle happening. That is related with our natural system. This chemical industry also, we need to have this kind of stream. What is called as, most of the time, we'll be having a recycle. Otherwise, there is a feed entering. It is going to a reactor to making some make some conversion, and in the reaction is not 100% complete. So we'll have a separation. So to separate the product and unconverted material. So unconverted materials are recycled back, and here again recycled back, and the total material, the fresh feed and the recycled feed. Or is here, this part is called as a mixed feed. So the mixed feed is entering the reactor, and it is undergoing some conversion. We need to have the separation of product and unconverted material. So whatever is leaving here is unconverted, here is the converted material product. So the recycle is very common, and there is a stream what is called as purge. Of course, as like product is also leaving the industry, but we call this as purge. Otherwise, this separator is unconverted material along with that. So whatever is not utilized in the reaction, like say for example, in the case of any oxidation reactions, say our sulfuric acid production, what we do, we use oxygen for the reaction. For oxygen is taken from air. So air is having large amount of nitrogen. Nitrogen is not utilized in the reaction. Say our burner and converter, they are the reactor units, and separator. Of course, in the separation, what is happening? Yeah, your sulfur dioxide is turning to sulfuric acid, and this simply what is it, absorbed, or it is from the gas content, from the gas, there is a separation of these materials like SO3 and SO3, which is simply separated by adding water. So you are getting not water, actually sulfuric acid. You are getting oleum. There is a product. So what is going in the purge? Purge is actually whatever the unutilized, whatever the nitrogen entering the system in the fresh feed is leaving in the purge. Otherwise, we should have this stream leaving. Otherwise, which will create problem. In what way? Because if you whatever the except the product, everything, if you try to recycle, you will see there is a large accumulation of this nitrogen in the system. We should have a provision for this nitrogen to leave. Of course, this nitrogen is leaving naturally in the plant because of the gases leaving this absorber. No? The gases leaving the absorber is simply having large amount of nitrogen. And of course, any unutilized SO2, SO3, and some amount of even sulfuric acid particles as well. So this otherwise purge stream is to remove the inert contents. So there are most of the time there are a lot of inerts are entering in the system. We should avoid this buildup of inerts, because whatever the this feed entering, I will remove this. Okay, whatever the feed entering, since it is having nitrogen, we should allow for this nitrogen to leave the system. So that is leaving in the form in the purge stream. Okay. Otherwise, recycled material, a part of material is left to the atmosphere. Otherwise, you need to have a kind of again another separator. But luckily, this in the case of our what to say? Yeah, okay. Most of the time, this purge will be having nitrogen. Sometimes even some reactive material also will leave the system. Okay, this and all you have to explore along with your chemical process industry flow sheet. We have only seen this two process, only sulfuric acid and another is soda ash. Likewise, a lot of at least another about 30-40 chemicals you will be going through in detail, like urea production, nitric acid production, and what else, like sugar production. So for a lot of other industrially important processes, you will see the this process units in detail in your chemical process industries course. Okay, quite something relevant. And people, you are also looking for some books. Try பண்ணுவீங்களாப்பா? How about book is reached you? Book has reached you? I think there is a delay in.
No, sir.
No, வரலையா?
இல்ல sir.
But for our subject or in the present days, no, a lot of books are available in form of online. Maybe I will give one part. In LMS itself, I have put up these contents. I'll give access to you people. There is, I will go to this LMS page directly. 1 minute, because I can add this content or I can give access to my book, online book contents. Say in the LMS itself, I have added this contents. I will give access to that page so that your I need not send you this book again. So there is a course relevant to GATE chemical engineering. Of course, I have put up this LMS page. I will add you people also. Enroll users. I can finish this activity now also. Cohort. SS and sorry, chemical 2021. You people are 2020, no? Beta chemical 2020. Sorry, now in the first year, so 2020 only. Beta chemical 2020. Why there is no such thing? Chemical. Okay, let's look for 2020. So 2020 chemical அப்படியே ஆட் பண்ணியாச்சுனா முடிஞ்சு. 1 minute. So you need not ask for book later, for at least for our my course. Right. So beta chemical 2020, I'm adding you people, everyone, for this course, and we'll see that. Let us start panadu. Fine. Aditya, Shankar, Aditya, Asresha. Okay, let us students check pandrathu. Fine. Yeah, you people also added to this this course. GATE CH will be listed in your course list, and therein which I have given this collections of my material on GATE. Of course, I am giving this. Yeah, I can also say about my elaborate about myself regarding this GATE. So this, you know about this GATE exam, which is for what is it, for higher studies in chemical engineering in India, or in IIT and NIT or in any other institute, and also for getting into this PSU, public sector units. You know, for public sector units like IOCL, BPCL, or ONGC, whatever the companies, they are simply recruiting people based on your GATE score. So for that, I have put up a lot of materials. Thing is, the books, I have put up these books in the Google Drive. So these books, like general books, you can go through, or even any other book on, for example, this concepts of chemical engineering for chemists. My screen is visible now, pa? Of course, this link is accessible by anyone who is having. You can easily simply click on this link and get these books. So for all the core subjects, I have given this nice. Of course, it is simply collection of various nice books. Say for example, you can go through this elementary principles of chemical processes. Nice book for you to go through. So likewise, you can go through any other book available here, and you need not ask for the book to reach. The book la படிச்சு பாருங்கப்பா. Nice books. Of course, whatever the classic books which are all available in soft copy are uploaded here. Of course, this is not supposed to be done because these are all copyrighted material. So since for our SSM students, I'm giving this access. Okay. Along with that, I can also say about this course contents here. I have put up some material on this about gate and what are the subjects covered in that gate. And of course, I can give an idea about this gate. And many of our students are seriously taking up this gate, but still, yearly some only about three, 4 students are in a position to get top scores of the order of about gate all India rank within 300, 500. If you are having a rank of within 200, there is a guarantee for you to get into public sector units. Otherwise, the salary will be of the order of about 15 lakhs per year. One of the nice student passed getting to this gate PSU through gate is our students, namely Siddharth and Pavan. Along with them, I have authored. Of course, I have ordered them as my co-authors for my subject, Gateway to Chemical Engineering, for the book. Okay, please go through these contents. The access is given to you. Of course, many others are in. Yeah, this my previous lectures on other subjects also available to you. You can go through them. Of course, I am making this in a full. Many of the contents are available for free, and I am also creating another LMS server, which is called as msubbu Academy, because my book is my book contents. I am making it in a interactive way in my website, new website, what is called as msubbu Academy. Herein I have put up this entire book contents in a soft form. Of course, for this, for accessing this page, I will be charging because for this I am working a lot, which is what is it? Sorry. So these contents are available. Okay, I'm yet to launch this msubbu Academy. Okay. Slowly I'm working on, maybe another about 2-3 weeks I will release this, but no need to worry. This entire necessary contents which needed for thing are available in our LMS Gate CH page for free. Always I have put up this old question papers of Gate CH and this relevant books. And of course, my book is not available in soft copy. Don't ask for that. Of course, I have also written books on chemical engineering. This for GATE chemical engineering, my books are preferred to the in a better way. What is called as I can search simply Amazon and msubbu. In Amazon.in, my books are listed. So this set of 5 books, Gateway to Chemical Engineering, 5 set of 5 books, released in 2018. September actually, and another book which is released in 2003 is Insight into Chemical Engineering. So you can go through about the reviews of this book. Of course, for my students, I am giving this book for relatively lesser amount, like 300 for this Insight into Chemical Engineering, which is MRP of 525. The another which is Gateway to Chemical Engineering book, MRP of 2000. I'm giving it to my students at a rate of about 1,200, maybe slightly I will rise also this year, 1,250 or 300. So always I'm giving as much as about 40% discount to my students, to our students. Okay, not my, our students. Likewise, okay, I need to say about this other book, which is Gateway to General Aptitude. This book was co-authored. Actually, I should say this was essentially the work of our 2 students, namely Siddharth and Pavan, since I need to update this contents. For about past 3-4 months, this book is out of print. The reason is again because of this lockdown. I'll go for print soon. This was printed in 2018. Okay, a lot of data to be updated. Okay, my book is available for purchase in Amazon. For my students, you can directly take it from me. Okay, these are all also giving idea about this for our subject, because since you are also waiting for book, you need not wait for the book. The book is now available to you in the from your LMS page. Okay, LMS like Gate CH will be available to you. Otherwise, I have ordered you people to this course. You can see the contents available. Maybe I will show you this as a student access. So the information by IIT in the last year and gate distribution, gate syllabus, marks, overview of gate. This last year we made a presentation. Okay. Okay, MCQ for practice, something are available. So other contents, my own class notes. Okay, this for the my book is converted into what is it, electronic access format in my new website, which is msubbu academy. Of course, I can also show you my other website, which is I'm using it for a long, which is msubbu.in. There in which of course I have provided my details and this lecture notes for the core subjects of chemical engineering. Maybe for fluid mechanics, you can also go through them. So some materials relevant to the books. That's why I am giving this idea. Okay, we have to finish today's class. Okay, we will discuss about otherwise we will continue from these aspects in the coming class, which is about process streams. So otherwise, we started discussing about the need for a purge stream. Purge is to prevent the accumulation of inerts. To simply say, the purge is to prevent the accumulation of inerts. So inerts are entering sometime because of the usage of air. Otherwise, also sometimes we also sometimes add inerts so as to control the reaction. Of course, you know the role of inerts in this based on your Lee-Chartier principle, no? Lee-Chartier principle, you would have come across this Lee-Chartier principle. You know the role of inerts. Sometimes having more material also helpful. Though they are not taking part, at least they will control something. Like at least they will help to prevent the buildup of temperature. Okay, that way the inerts are doing a role to play. Even in the class also, no, sometimes the class will be better if people are at least about 60-70 people, and though they are not taking part in the class also, at least it's giving an idea like at least we are addressing to a large class. Okay, but no need to see. Of course, everyone is trying to take part in the reaction, but sometimes without undergoing any reaction also they may leave the system. Okay, we will discuss this in the coming class. We will continue from this and we will try to finish the next aspects like conversion, yield and selectivity. Okay, the first Monday class la mudichiruvom, and if the test is starting up in the next week itself, then we'll have a quick review. Maybe possibly we'll conduct some we'll give you a practice quiz also. Whereas if they are still delaying, then we'll take up the next topic, which is fluid mechanics. Okay, attendance will be easier now, like because you have written this way. The Dharmesh, you can rename yourself to simply 11 because this 0, 11, 11 means it is going to the top. Okay, number 2 not available, Appa. Aditya, yes. Nice. Okay. If possible, you can rename yourself. Okay, that is for the next class onwards. Number 3, Abhishek. Number 4, 5 available. The 46, please rename 046. Veru 46 rename pannunga. Okay, 5. Number 6 not there. 6 yarba. Aishwarya, right. Number 7 was there in the class. Amrita Varshini also no though there. Aravindan irkingla.
Present, sir.
Right. Number 10 irkinga. Right.
Yes,
Dharmesh was there in the class. Okay. Number 12, Dravya Devi. Number 12 irkingla ma? Dravya Devi. Okay. No problem. I need not call you people. Number 13 is not there.
Sir.
Okay. Silent it will be there in the order. If you try to okay. Okay, 13 is also there. Okay, silent I will note down these arguments. That means 18 also there. Fine. 22. Jayshree should be there.
Present, sir.
Seri, okay, right. 23, 24, 25, 26, 27. Yaar baadu Nitish irkingala?
Yes, sir.
Then okay, fine. Neravi கூப்பிட்டுக்கலாம் இல்லையா? Right. 31, 32.
Sir, 32 present, sir.
Right, rendu பேர் இருக்கீங்க. Nice. Santosh GDP normally will be available.
Sir, present, sir.
சரிப்பா, right. 34, 35, 36, 37. And I thought of avoiding you calling. Call you have to be alert. Of course, the present இப்போ இருக்கிற சிஸ்டத்துல நம்ம எல்லா நேரமும் மொபைலை பார்த்துட்டு இருக்க முடியாது, மொபைலு கம்ப்யூட்டரே பார்த்துட்டு இருக்க முடியாது. வேற பக்கத்துல கிளாஸ்ல we are now using these electronic devices always a lot. That is also affecting our eyes. அதனாலதான் உங்களுக்கு கிளாஸ் எல்லாம் குறைச்சு போட்டுருவாங்க. 3 hour போட்டதுக்கு காரணம் தான். ஒரு நாளைக்கு 5 hour தான் மேக்ஸிமம் அட்டன் பண்றீங்க இல்லையா? எஃபெக்டிவ்லி 3-4 hours only are attending. இல்லைங்க, யாரு இல்லன்னு தெரிஞ்சாச்சு. ஆல்மோஸ்ட் 2-3 பேர் மட்டும் இல்ல, யாருன்னு தெரிஞ்சுன்னா நானே விட்டுருவேன் கிளாஸ். ஓகே, இது வரைக்கும் போயாச்சு. ஓகே, இட்ஸ் கிராண்ட் ஆர்டர் 36 வரைக்கும் போயிட்டோம் இல்லையா? 35, 36, 37, 38. Better I will call people, no? The rest of the people. Ranging from number 34, Sarath Kumar.
Present, sir.
Okay, pa. Akshata, Siva Shanmugam. Akshata, okay, Akshata.
Yes, sir.
Okay, ma. Sri Ram.
Present, sir.
இது பாக்குறது ஈஸியா இருக்கு. சிவசுப்ரமணியன்.
Present, sir.
Sonika.
Present, sir.
Varsini, Sri Varsini.
Present, sir.
Yeah, Swati Krishna was available.
Present, sir.
Okay, Sweta. Tarun Kumar.
Present, sir.
Tarun Kumar, okay. Sweta, இருக்கீங்களாமா? It to get any sound. Sweta, okay, I suppose Sweta is not there. Okay. Divya.
Present, sir.
Umaya. Umaya இல்லையா கிளாஸ்ல இன்னைக்கு?
Present, sir.
இருந்துட்டீங்க. Vaidish.
Present, sir.
Okay, pa. Vaishnavi.
Present, sir.
Okay, then Varsha.
Present, sir.
Varshini.
Present, sir.
Right. Varun. So Tarun, Varun. ரெண்டு பேர் காணோம். Right. Sorry, 50, no? Is 50. Then Varshini present. Okay. Vivekananda.
Present, sir.
Okay. Vidya.
Present, sir.
Vignesh.
Present, sir.
Guru.
Present, sir.
Yukesh. இருக்கீங்களாப்பா? Okay, I will repeat the people those who are not there in the class and say Tarun. What is it? Tarun Kumar.
Yes, sir.
Oh, இருந்துட்டீங்க. அப்ப யார்? ஸ்வேதா ஆப்சண்டா? ஸ்வேதா also present. Sweta K. Okay, I'll give attendance for everyone. No problem. Leave. You can leave the class.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. See you all in the next class.
Thank you, sir.
Next week. Thank you, ma. Varsini, Sri Varsini.
Thank you, sir.
Thank you, ma. See you all in the next week.
Thank you, sir.
Thank you. Have a great week. End,
Thank you, sir.
Yeah, right, ma. அஸ்வின் குமார் ஏதாவது பேசணுமாப்பா? க்ளோஸ் பண்ணிடலாமா அஸ்வின்? ஓகே, ஐம் க்ளோசிங் பா.